Hey Tony,
Hey Drew,
how
we are
are
live. Do you hear me well?
I hear you perfect. Yep.
Perfect. It's not noisy.
Not noisy at all.
Okay, perfect. Because I changed my computer and I wasn't sure if it was working well. So we are live, and yes, I will share my screen. Yes, entire screen. I think it's better so that we can see everything. So you see my screen.
Yes, sir.
Cool. The sound is great, and
Sound.
I need to watch your podcast.
That was the first podcast I've ever done. It was pretty fun.
Yes, I was it was at Wise. Sorry, I was thinking, so I will watch it. I think this weekend.
It's only 30 minutes long. You gotta let me know what you think.
Yes, I
Be
tell
mean.
you.
Be mean. I gotta improve.
Yes, we all can improve, and at least for the first time, it's always a bit new.
Yes.
Okay, so we're waiting maybe 2 minutes as always.
That
I
is
will
fine.
put that in the chat. And maybe in Twitter we can say that we are live. Now we can close that. Go back here. I'm sure you know about signing stuff.
Signing. Oh, for the topic today. Yes.
Yes, because I've seen a lot of your videos, and signing it's a important topic.
Yes, it's very important. That's probably like the biggest confusion for most, or I don't know about that, but people don't know what signing is at all.
Yes, but it's because it's not super intuitive, and we don't have nothing in the concrete world to relate with that kind of a signing, I think.
Yes.
But anyway, we are going to do something to this, and okay, so we go. If you're
Let's
okay.
party.
So we're going to see it's going. Can you tell me if now you see my terminal?
I see your terminal. Yes, sir.
Okay, so we are perfect, and we can start. And before, hey everybody, for the one that will see the videos after in the recording, we think about you right now and after. And before we start with the sixth part of Core Lightning implementation of Bolt 11 invoices, let's recall that that Core Lightning is partnering with Sphinx community, and there are a bunch of bounties that you can see in that link that I will put in the transcript too. And you can see you can earn SAT and stack SAT by solving some of the issues. And I think that one has already got paid to Veras. So really cool initiative, and a fun way if you are a programmer to stack SAT. So here we are with the bounties. Okay, and maybe now we can start talking about signing. First thing first, I'm not a cryptographer, so maybe I think that that session of today would be way better, and I really would like to listen to a cryptographer to do it, but but I will try to do my best today to explain to me and to you how Bolt 11 invoices are signed, and we can jump in here. And as we've seen, sometime we write a lot of code, like last one where it was we write a little project with a lot of code. Sometimes we spend more time reading and looking around in the Core Lightning repositories to see how things are done. And this is more what we are going to do today. So we are going to try to get how to say that, a feel and to see where to look at if we need those information about signing Bolt 11. And there are still some part that, of Core Lightning and in the cryptographic part of the signing that I don't understand, but I think that we can do something cool today. And I love reading code, so we are going to do that today together. So let's, the first link is I have on my computer the Bolt clone, and we are going to look at payment encoding, which is Bolt 11. And we are interested in the part that say that we need to sign some data that is in the Bolt 11 invoice. So we go to that section, and we recall that a Bolt 11 invoice has several parts, and the first part is a human readable. Then we have one that separates that part with the data part. We have the data part that contain, as we can see here, a timestamp, several tagged parts. So we talk about that in the previous session. So this is where, for instance, we put the description, and at the end of the data part, we have the signature, and this is what we're going to look at today. So we are going all the data that we encode in and we send. The first part of the invoice is signed with the Bitcoin style signature, and after that signature, we have 6 base32 characters, which are the checksum of the entire base32 encoding of all the information. So we concentrate today in the signature part, how it is done in Core Lightning, and maybe looking at what is a signature and why this is 520 bits here of signature, and not 512. So this is we are going to see that in a moment, and we can see we continue to look at what is written in the Bolt, and we see so the signature. This is 512 bits of the SEC P266K1 signature, of the SHA-2 266 bits of everything before. So all the information that we have before, so the human readable part, then the timestamp and the tagged part, we do a SHA of this SHA-266, and that part, this is what we sign, and the signature, we put it in the invoice, and we send it. And at the end, we see that we have a recovery ID, which is 0, 1, 2, or 3, and that have to do how to say, with the signature. So this is something that we can have, and with that we can recover the public key that we use for signing. And so from the public key, we can recover the node ID. So when we sign, this is 8 bits at the end that are put in it. So does we have something else to look at here? No, so we don't need to look at more stuff, but we are going to go down to the bottom, and we see we have a section with example, and we are going to use the first example because we are going to run one of the tests. So with this example, they are reproduced in the test file of that specific part of bot 11 in Core Lightning, and we can use one of the strings to understand what is done. So we see all the examples here, and we are just looking at the first one are signed with that private key that we have at the top, with a payment secret that is those ones, and a description. Please make a donation of any amount, blah blah blah, using some payment hash to me. So, and I think that this should be the node ID, I think. And this is the if we implement, and this is the case in Core Lightning correctly, the encoding of a Bolt 11 invoice, we should get that invoice. So we copy that invoice. I will see if we are more. No, we are not more, but we continue. So let's take that invoice, and we can look at that at the beginning, and we have the chain here, and I think that there is a 0 amount, the separation, which is the 1, and then after we have some data. At some point we encounter the signature. At the end, I just told, so this is a beg32 string, so it is encoded with the algorithm specified in the BIP 173 that we've seen in the last episode. And we see at the end, this is the checksum that doesn't contain information related to the invoice. This is just the checksum of the algorithm that is used. So check sum 1, 2, 3, 4, 5, 6. So we have 6 at the end, and the last part here should be a signature. So the signature is I will write this here, 520 bits. Okay, so 512 plus 8 bits of the recovery ID, and we divide that by 5. Why 5? This is because we remember, so the beg32 car set, the characters that are used to in that string after the 1, after the separation 1, so that we have here and also in that checksum, are only 32 characters. So on 2 to power 5 is equal to 32. And what we need to do when we have 520 bits, we can see that at a number of bytes of 8 bits, or what we want is to, when the conversion is done, when we have the signature in bytes of 8 bits, we want that in 5 bits, because we want to encode it with the car set which had only 32 characters. So we need to divide it by 5. So to not make a mistake, so 120, this one, and we divide by 5, and we get 104. So the last 104 character are the signature. So let's jump to those characters. So 1 04. We go here. And normally, I think that I should have cut the right number. So yes, I cut the right number. So now we have data, HRP human readable part, and here we have the signature. Normally, this should have been done correctly. We can check that with the command that we have in Core Lightning, which is called decode, and we are going to decode that yes, okay. Sorry, so 1 second. Stay with me. Huh? So we have one invoice that is in an example of the Bolt 11. We've seen how we recuperate the signatures that is at the end of the before the checksum that is only 104 characters. And yes, I will just start Lightning Dog running on regtest. We are going to decode that string, see the decoding. We are going to see the signature, but written in hexa, not in a Beck 32. And then just after, we are going to jump into the test file to see that invoice in place and to see how the signature is done in Core Lightning in the test part. When we've seen how it is done in the test to test it, we are going to see in the Core Lightning code the resemblance on exactly how it is done, because if I understand correctly, in Core Lightning there's a HSMD daemon that runs separately. It's a subdaemon of Lightning D that is responsible for the signing. So he owns the private key of the node and is able to sign not anything, but the thing that we ask him to sign. We send in the data we want it to sign. He sign it and give us back something signed. So this is how it's done. But in the first place, we can see the function that compute the SHA-256 of all the data that we have before with the human readable part. Sorry, so human readable part maybe stop before the one, because the one is separation. No longer sure if it. I think this is this should be the case, something like that. Anyway, so we are going to see there are two things to distinguish how this is signed and who can sign it in Core Lightning, which is as far as I understand is HSMD. So let's start a terminal. I have in repo I have Lightning cloned there, and we can do contrib, startup regtest as we do often. Now we start two node running on regtest, and I hope this works. We can check that. So we have this alias for the first node. So let's just look at it. So this is Lightning CLI, but with the specific directory temporary L1 dash regtest. And now we can check that maybe we have the something running and we have the node info. So, this is fine. And now we want to decode something. So L1 dash CLI decode. So we are going to decode. Okay, so we split it totally. So maybe we can go to that payment, get it again. So we are going to keep it at the top. We go back to that terminal. Is it that one? why do I have two terminal? Anyway, we go back to this one. We passed it, we decode, and at some point we have that signature. But we can see that that signature uses hexadecimal encoding to do that. And we can see in the note here that the signature that we have is in BEC 32. So what do we want to do now? We want, so I will drink a bit of water. Okay, we want the signing. So in that file, so in the Lightning repository, so I am at the top, we have in the common, so this is a subdirectory with a command module, so we can call it like that, and we have the module Bolt 11, and that module is tested with under the directory test run Bolt 11. So let's jump into it. So maybe you can see at the bottom and the line vert, so the mod line here, we are in the Lightning directory with the name of the file in that in the Lightning repository, so that we can see that. So here, this is the test file that the test Bolt 11 implementation, and we have some functions that we are going to look at. I think that in one of the episodes we've seen we've looked at that file. So if you missed the previous episode, you can watch them. Normally, all together, there are something coherent where we can we touch at many parts of Core Lightning, and we should understand how it works. So we see what we're doing at the beginning of that main function of the test file. Okay, so we are in the main function. We recuperate the private key. So we load in some way the private key, and we put it in the private key struct that is here, and is defined at the beginning. So this is what I was telling before. We need the private key to sign any data, and in the test we provide that private key, and we don't care of the security to have them or to lose them because of people using it, because this is for testing. But this is an important topic and a careful topic, and this is done how the private key, as far as I understand, where it is and who can access it, is done by the subdemand HSMD. Okay, so this is that thing, but we have it. So when we start the test, we load that private key. And this is almost all that we want to look at. Almost all. Huh? Okay, so so we built here. This is exactly what we have in the Bolt 11, the first part that we've seen, and we are testing. Are we capable to construct the how to say that? To construct the Bolt 11 invoices that should be this. So this is the vector test, and this is the one that we were playing with before. To do that, we see that we create a new Bolt 11 struct, and we can see after that we put a bunch of stuff in that struct, and with that struct, at some point we pass it. So we see here we set the field, the description of Bolt 11. So please consider supporting this project. We set the feature bit of the features field of B11, and at that point we test we test if it works. So we pass it that string. So the result, what we want to be sure we have, and all the information that are in that B11 struct. So with that B11 struct, we are going to test the function that is called encode something. So we are going to see it just after in the test function. And that test function is up in that file. So we can see in that file we have three functions. So we have a test assign, which is the function that we are interested in understanding today. We have the test B11. So we see we pass it the strings that we want to get, and we pass it that struct B11 with the information to build that to build how to say, to build that invoice. Okay, so I hope this is what I'm telling you is clear. And what we do now, okay, so here we decode the bolt 11 string, because we are after what we do is that we compare. We do at the same time the decoding and the encoding, and we compare if things are correct. But the part that I would like to show you, and this is the part. Okay, so this is that one. So this is that function. Okay, so bolt 11 encode. We pass it a temporary context. So this is for the memory. B11. This is all the information that we have, and we want to encode in the bolt 11 string. And we have test assign, which is the function that is responsible for the signing of the bolt 11 string, and then bolt 11 return that string. And in that part, as we are doing a test, we are comparing if each character is the right one. But we have that function bolt 11 encode that uses that have as argument the test sign function that signs something, and we'll use the information in B11 to do the signing. So I hope this is clear. Is it clear for you, Drew?
Yes, sir.
Okay, so I will drink a bit of water, and we continue with that journey inside the code. So what do we want to look at right now? So I tell you that bolt 11 encode is where we do the encoding, and we use a function that is called test time, and that do the signing. There are two things that we can do is look at bolt 11 encode, or wait a minute, I will just look at where it is defined. Okay, so this is defined like that. But I'm just thinking about the order I want to present that. So maybe let's run something. Okay. So okay, so we are going to run something, and I see. Okay, I try to be clear. if I not, sorry, I would have tried to explain that part of Bolt 11 invoices, and that's it. So. Now, okay, I prefer to go where no. Okay, so sorry. Let's go. We go back. We have that function, and we pass that function in that function. Okay. So what we can do is we are just going to see how it is signed, and then we are moving on in another part and see that when we have that signature, when we in the real life, not real life, but not in the test, that signature should be put in the how that signature is used and transformed to be put in the as we see in the note here, that part at the end, when it is done and how it is done in the Encode Bolt 11. But let's see the signature. So we assume we get two types of data when we okay, so this is a function that is called in that previous function that is called Bolt 11 encode, which is a macro that called Bolt 11 encode underscore, and inside that code we calculate and we have the information about an array of U5 and an array on the string of U8. So HRP U8 and the U5 bytes. So the U5 bytes are all the data that we get. So if we go back to our note, this has these are those data. So this is and this is a U5 because they are integer between 0 to 32, and the human readable part is the part before the one, and we do we pass it sec266 K1 ECDSR recoverable signature. So this is that in that pointer we are going to put the signatures that we want that we use and encode in Bec32 at the end. So what we do there is that we copy the HRP and we start to do a SHA-256 with all with the HRP and with the U5 bytes. And when we've done those SHA, this is put in that variable SHA, okay, and which is a SHA-256 struct. And now we call that function to sign. This is where we sign, and to do the signing, we need the SHA. So what is the information that we want to sign? This is that one. The private key, this is in this, and we've seen at the beginning when we start the main function in the test that we sign that that function. But when we are in the code running Lightning node, we get that that private key from in HSMD. So we call that function. This is HSMD that call that function which do the signing, and we put everything in recoverable SIG, so R SIG. Now let's see. That function is called for every function test that we every Lightning Bolt 11 invoices that we have in the test. We're going to go in the note, because we have some function that let us print out this. So I just passed it, and as we need. So let's put that here. Type to string, maybe it should be there. So in type to string.c files in the common directory, we have utilities that we can use in the Lightning repository to print some of the struct that we have. And in that case, this is something that we've seen in the previous episode, but I recall it. So this is how to use it. So we want a string, so type to string. We pass it context, and we pass what the type. Not every struct or type is can be used, but it happened that we can use the ECDSA signature, this one, so that type. And the raw signature, the recoverable signature that we have, in fact, is not it's not 64 byte, but 65. So because we have the last part, which is the recover ID, so we just we cast it to the right one, so that we normally are going to be able to each time we test one Lightning invoices, we are going to be able to print that one. Okay, so now we compile that file, and it should be done in a few seconds. Okay, so now we can open a new terminal, and we go to that part, and we can call, so command test, and we run the test bolt 11. We have this one. Normally we would see nothing, because if the test run, it's okay, but we want to print the signature. So here are all the signature that we add with the data that we have on the first one. So we can take that first one, we copy it, we go to the note. Okay, we are going to paste it here. So this is the signature, and it corresponds to the first step that we do in that file, and it is done for that that invoice that we should get. And if we go back to our first terminal, and we take the signature that we have by decoding, and I will paste it here, we see that this is the same. Okay, so it seems a long time to get to that part, but anyway, I hope we still are with me, and this is in some way helpful. Okay, so when we have the information, so, and we sign that information, and that information at some point we need to transform it into a BEC 32. with the base32 character that here because we want to put it in the final bolt 11 string. So now what we are going to do, so we are in the test. Why were we looking at test sign function? Because this is that function that is passed to the bolt 11 encode macro. So that means that at some point it is used inside. And we've seen that we construct all the information about the invoice except the signature is in the struct B11. Now let's look at that macro. So that macro takes a bunch of arguments, and in fact is calling that function, and I think this is used only to do a type check on the function here. I don't know exactly how it works, but this is my understanding. It's just to specify the sign function, the type of the sign function input argument and output argument too. So now we need to look at that function. Okay, so bolt 11 encode underscore, and that function is defined. So we are in the directory command. We go into bolt 11 that one, and I will try to go a little bit faster, just for one thing, because I would like to show that the HSMD part, even if I don't understand it really well, I want to go there. So this is bolt 11 encode, and if we go back to the test file to run bolt 11, we see exactly what we are passing there. So test sign, this is a function, and the goal of that function really, so we go back there, is to take the third argument, this one, and to put the signature in that argument. And then with that argument, we are going to use it and do something. So when we encode here, we see that the bolt 11 struct here, so that argument contain already at that moment all the information about the invoice that we want to produce. And now we have also the function to sign, and we are going to set this one. So this is an important part, and we are going to see what is happening. So now that part is not the recollecting of the information about the invoice, but it's really the kind of the last part where we transform every information that we have in memory, and we put it into a base32 string. And just before we do that last part, we need to sign that things, and we put that in the rsig recoverable signature that we get from this. And we can see here sig and recovery ID. That one is really because when we are going to sign, we are going to get the signature with another argument, which is the recovery ID, and we put it at the end of this. So let's see how it goes now. And we have the human readable part. We've seen that we use that one. So here we are constructing the thing. So blah blah. Let me, because I want to go to the end. Maybe we can. one moment, please. Okay, so here, okay, see if I'm not wrong, we are dealing with the human readable part in here. Then we push in the data the time stamp, which is 35 bits. Then we continue, and we see now each time we have a function that is called encode underscore something. For instance, with the S, this is for the secret. So we take here the secret information, and we encode it in base32, and we put it in the data in base32 or not. We see that that array is an array of U5. So we want number between 0 and 32. So, sorry, we continue. I will stop to say sorry. Just I do my best, but I think I hope this is anyway. This is the clearest I can do so far. So what we do is that each time we add some more information on that array. So we grow the array data with number between 0 and 32 that each one represent one information that we have in the B11 struct. And if we go back to or not, what we see is that we are constructing that array, that data array here, but not this final one with base32 character, but with the reverse of those characters, not the reverse, but the bijex, the number between 0 to 32 associated that gives us those characters. And so now this is the payment hash, and we continue the description down. And when we have all that information on the HRP, we are going to be able, at that point, we see to so this is here. Where is that function? That function, we call it sign. Okay, this is here at that point. Okay, so we have the function sign, which the only goal of that function. So this is really, it's in that case, sign is not as straightforward as that one that we see here. Okay, straightforward in the sense of here we have the private key. Okay, so this is the only difference. This is why there is something else to do with that other function that is sign. That in fact, when it is called, when we create the function, is an HS. It is a call that is done to HSMD to do the signing. But if we remember what we've been printing at that point, that function test sign, the only goal, and we see there, because we printed the thing, it was to set the recoverable signature R sig. And this is here, this is done with that function, okay, from the library secp266k1. And now this is what we do with when we sign here. So I think we are good in time. And I will try to stay condensed the content, not to expand too much. There are much more things to say, but at that point we sign. We continue a little bit to see when we have that signature, what we do after. So and then we are going to look at that sign function. Which sign function is used in Core Lightning, but we know that that one set this to the recoverable the signature with that recoverable part, and that take that HRP that we have built before on the data that is an array of number between 0 to 32. So inside we do SHA-256 of everything, and we sign that SHA and we set the RC. Now there's something that we need to do, because if we just do that signing RC that we have, it's not exactly that things, because this is a memory in-memory data that we have. So this is a representation, but this is something that that is not that we have to transform a bit before, and then we pass it to another function to transform it in that part in back 32 character. So we are back in that thing, and at that point we use that things that serialize. So we pass it, the argument that we pass it really is that signature, and then we get back that the 64 bytes, first byte of that array will be set to the signature, and then that variable takes the recovery ID, and at the end, what we pass, we set the last part of sig on rex ID. We put it the recoverable ID, and now the last thing that we have to do is to push. And this is exactly what we did in the two last session, which is when we have sig and reseed. So this is an array of 65 character of 0 to 266. 266. Yes, yes, this is our U8. Maybe not 266, but 180, 128. But anyway, they are inside the int, and we transform it. We push it at the end of the data as number of length number between 0 to 32 on the. We do that by changing the ordering of where we cut this array of when we look at it as bits. So this is at that moment where we push it in the data, and then finally this is that part that that lead to get, if we go to the node, to the entire things. So. Are you still with me, Drew? Just
yes. Sorry.
No, it's okay. It's just to talk to someone. Do you have any question, by the way?
I have no questions right now. Just trying to keep up.
Okay, so let's go. We have 7 minutes left, and I think that for what I understand, this is I think I hope this is enough. So what is left is that part. This is the signing function. Okay, so. And we've seen that the signing function, in the case where we have in the test where we have access to the private key, it's trivial because we just have it and we have nothing. Not that we have nothing to do, but we just do a SHA-266 of the information that we want to sign. We pass it to the function that is implemented in another library to do the signing that set variable r sig, and then we do whatever we want with that thing. But when we don't want to have our private key anywhere in the software, but placed in some good place, so this is the part that I'm not quite understand, but I think this is what's going on. So let's we go back here, and now what I want to do is we are going to look to bolt 11 encode, because that function is called, it's called, so let's just do a grep here, and I want it in invoice. Okay, so I did a grep of that function, and we want to see when it is called there, and here we are. So invoice incomplete. So this is what we've seen, I think, in the first episode or the second. At some point, we run L1, we run Lightning CLI invoice. We pass the information. We do some the software get that command and say, okay, we have something to do. We build some information. We need the root to build the root field, and we need to call some plugin to do that. We go to invoice complete here. At the end, we see that this is where we construct the JSON that we return. So this is what we are used to in with the interface with the Lightning CLI interface and the JSON APC command invoice. So this is where we have that things constructed, and at that point, this is where we do the transformation and the encoding. And we see that now the function that we call is no longer test sign, but is HSM sign B11. So now what we are going, but we remember when we are in that function bot11 encode, okay, so that signed function, its only goal is to recuperate in some way the private key with the data that are in a B11 struct or bolt11 struct. We want to sign that with some utility, so with the library secp256k1. Okay, so we have that, we know that, and we set we have that signature, and with that signature we can now push it into the data that we want to in the last things finally to transform into a beg32 string. This is what we do. So we remember. Now we are going to look at that function, but remember the goal of that function is to sign something, okay, and to set one of the variables that it get to the signature. And now we are here and we say, oh, I don't know you, but for me it was a bit. It's always the same thing when we don't know where to look, and you didn't write the code, you don't know exactly how it works, but you have an idea. And I was there and I say, okay, I understand that rsig, that variable that we pass to the function need to be signed. So sorry to insist state, not to be to go back again there in the bolt11, but when this is really rsig that we want to set, okay? And here it's really obvious what we are doing. If we look at that, it's really obvious because we have that function, and we just have to look at that function, and that tell us that okay. So let's look at the definition of that function, and we see exactly the parameter, and we see that the output of the calling that function is really to set sig, and in our case it's called rsig, to pointer to an array where the signature will be placed. So when we see that, we go back here, we see what we are doing. Okay, so but when we are here, With the HSM sign B11, it's not that obvious. Okay, this is normal because we don't have access directly in Lightning in the invoice files to the the private key. If we have access, if I'm wrong, please, Drew and the people that are going to watch the video after, if I'm wrong, please correct me. And I love to. It's not that I love to be wrong, but it's like that when we don't know, we are not. I'm ready to learn what is really the thing, but we don't have access to the private key. So what do we do? What do we do? Is that we do something here. So we basically what we say is that we send something to the HSM with the information, and there those things can be signed, and we get back the receipt, and we see that. So I think that at that point, what we are doing is that we are sending to HSM U5 bytes on the HRP, which is a human readable part. We send that because these are the functions that we want to do a SHA of those not function, but the data. We want to do a SHA-256 of those things, and this is what we want to sign. So we send it to HSMD, and after here with that function from HSMD signed invoice reply, what we do is that we recuperate in our SIG the function signed if everything goes as expected. Now, so this is we are really at the last part of everything that I would like to see. Okay, so sign the invoice. So here, this is that function. What we do. So we are sending things to HSMD. So this is my understanding, and we see that the first we send that variable that which I think is a number that just say that when we are going to receive, that say, okay, this is what we are doing is signing for an invoice, and then what we have to send are the data part and the human readable part, and in another part we received that, and this is we go back here from HSMD sign invoice. So now we recuperate it. Okay. So this is where okay, so I hope this is clear what I'm doing. I need a bit more the understanding of that, but one thing that let's go into that HSMD. So we are in the HSMD warrior gen, because that file is generated by another files. And let's go back. So I remember we have something. So this is not here. Okay, so that one. So I will just look for something because I want the function. Okay, so this is in lib HSMD. Okay, I remember now. So in so this is not this one. Let's try if this is that one. Okay. So that function in lib HSMD, this is the one that seems to handle the message. So we send some messages, and if the first part of the message that we have is, for instance, that one, so wire HSMD sign invoice, which is the one that we send when with the function that wants. How do we under that? And this is the part that is important. Under sign invoice, that one. This is the one that will under the message that we received. In the message, we have the the HRP and the data. And now we want to sign because this is HSMD that is responsible to do that work and have access to the keys. And we jump to that function which is in lib.hsmd.c, and we can read there what it does. But now we see something. So I will jump back to the test, and we see now that this looks like what we have in the test function, where we are constructing the SHA-256 of the HRP and the data part, and then we sign something. And let's go back and see here. So we construct the things. Okay, we continue. Now we see that this is exactly what, not know if it exactly, but this is the thing. Not key. So this is here. Okay, the difference now is that we need the private key to sign, because before we couldn't we could sign because we have the private key hard coding in the test file. But now we need to recuperate that private key, and we store it in a node pk variable, and then now we see that we are signing. We signed, and we can see that are we using? Yes, we are using exactly the same function. So let's go back here. So we are in lib.hsmd. We sign, and now the private key is the one that we get from a node _key function, and this is why we had to do all those things all together. We set that recoverable signature, and when we've set that, as we are in HSMD, we need to, if I understand correctly, we need to send it back to the wire. So we send that signature, and let's see if we can go back to there. And I think that this is what we get in that function. We recuperate from the wire the rsig, and when we have that, this is exactly what we wanted to do with that function HSM sign B11 that we use. So let's go back. So I jump back, and we see we are back into the invoice complete, and where we pass to the function bolt11 encode to the macro the function HSM sign B11, which is responsible to do the signing. Okay, so this is I'm over 8 minutes, but I wanted to do that part, and that's it. I couldn't talk talk about the part which is to say what is a signature, a bit cryptographic signature, ECDSA, but we have to pick and choose what to show. So the goal in those sessions are more to talk about how things are implemented in Core Lightning, and when we can, we talked also about what is signing, but we jump in the repository. So I hope this is useful, and you can find information if you want to go more. Anyway, in LN Room, so I will show you. So LN Room. So in that website, I put lnroom.live. I put every live on the other videos with the transcript, and generally, let's see, maybe to this one, I used to put a section resources. Okay, and I put resources that help me generally do the live, and there are some of them that are helpful to understand that recovery ID of the elliptic curve and what are elliptic curve, what is signing ECD SA. But okay, guys, that's it for today. And yeah.
Awesome. Thank you, Tony.
Thank you, Drew. Thank you, A. And see you in 2 weeks.
Sounds like a plan. Bye, everybody.
Bye.